Okay, so what you need to have ready to go is this, the very first page in your packet, the sum and difference formulas. You do not have to memorize these. Okay, you'll have these on the test. And your unit circle. So have that out and ready to go. So what these formulas will do for you, it helps you find an angle that's not on the unit circle by using the angles on the unit circle. Okay, so there's not a lot of, you will be taking your own notes on your own paper, but there's not a lot of stuff for me to write. I'm just going to be referring back to the formula sheet and the unit circle. So our first example is use the subtraction. Now I'm going to have to get a better marker than that to show up on the board. All right, use the subtraction formula to evaluate man, these are not good. The sine of 105 degrees without a calculator. Of course, you can check it with your calculator. But you have to get the answer. Let's see if I can shoot this thing. All right. So we're trying to find sine, so you've got to look at a sine formula. And we're going to use a subtraction formula. Okay, so what you want to do is find two numbers on the unit circle so that when you subtract them, you get 105. Okay, I usually like to use one of the 45-degree angle ones on the unit circle. Okay, but so you could do, to get 105 degrees, we could do sine of, there's a lot of options that you could pick, but sine of 105 degrees is going to be the sine of a couple of angles on the unit circle. Let's do 150 degrees minus 45 degrees. Now you could pick anything you want as long as they're on the unit circle, and when you subtract them, you get 105 degrees. Okay, so using the sheet, sine theta 1, so this is theta 1, and this is theta 2. So the formula is going to be, just looking at the sheet, sine of theta 1, so sine of 150 degrees, times the cosine of theta 2, which is 45 degrees, and I don't memorize these either. And since it's subtraction, then you would minus. So see how this is, I'm going through the first formula on here, and then you switch them. Cosine of 150 degrees times the sine of 45 degrees. All right, so it is the first formula on there. We're using the sine formula, and we're doing subtraction. Okay, so on the unit circle, tell me what the sine of 150 degrees is. Okay, 1/2. And then cosine of 45 is root 2 over 2. What is the cosine of 150 degrees? Negative root 3 over 2, and then times root 2 over 2. So we're going to multiply those together. That's going to be root 2 over 4, and then minus minus would make a plus. Root 3 times root 2 is root 6 over 4. So let's put them together. It's root 2 plus root 6 4. All right, so just to show you how this works, and that it works with any angle that you pick on the unit circle, I'm going to work the same problem, sine of 105 degrees, but use two different angles in 150 and 145. So you could also do sine of 105 degrees, and we should come up with the same answer, is equal to sine of, we could do something minus 30. So how about 135 degrees minus 30 degrees? Both of those are on the unit circle, and that'd give you 105, right? Okay, so that's going to be sine of 135 degrees times the cosine of the second one, 30 degrees, minus cosine of 135 degrees. Times the sine of 30 degrees. All right, again, you don't have to memorize the formulas on the sheet. Just use the sheet. So looking at the unit circle, what's the sine of 135 degrees? It's like root 2 over 2, right?
Yeah.
Cosine of 30, root 3 over 2?
Yes.
Check me. All right, cosine of 135 should be negative root 2 over 2.
Yes.
And then sine of 30 is 1/2. You'll get the unit circle on the test, so you don't have to memorize it. That's going to be root 6 over 4, right? Root 2 times root 3, root 6, 2 times 2 is 4. Minus minus would be plus root 2 over 4. So that's root 6 plus root 2 over 4. Is that the same thing as root 2 plus root 6 over 4? Same thing, just a little different order. It's the same thing. So that just goes to show you how you can pick whatever you want. You could also do an addition. You could do 60 plus 45 and use the addition formula. All right, so that's all there is to it. Everybody caught up? Anybody still writing? Old markers. It's not going to make for the best video. Okay, the next one is use the sum formula. All right, sum, so we're going to use a formula that's got a plus in it to find cosine of 75 degrees. Okay, so cosine of 75 degrees is equal to the cosine, and I need two numbers on the unit circle that if you add them up, you get 75. All right, 30 and 45, so I'll do it, we'll do 45. Since it's sum, we have to use the plus 30. All right, so this is theta 1 and theta 2. All right, so let's look at the formula sheet. So the second one on the list is the plus formula for cosine. So that's going to be cosine of 45 degrees times the cosine of 30 degrees. And then there's a minus in the plus formula. All right, so it's good you don't have to memorize. And then we have the sine of 45 degrees times the sine of 30 degrees. So does everybody see where I'm getting that from? From the second bullet on the list. All right, so cosine of 45 on the unit circle, that's going to be root 2 over 2. Cosine of 30 is root 3 over 2. If I make a mistake, somebody check me. And root 2 over 2 for sine 45. Sine 30 is a half. That's going to be root 6 over 4 minus root 2 over 4. So that's root 6 minus root 2 over 4. Okay? So your answers are going to have a lot of root 6s and root 2s in them. You can fast forward through that part. All right. So let's do one with tangent. So we want to find the exact value. When it says exact value, it means not a decimal number. Okay, it's going to be a number that has radicals in it. Okay, so find the exact value of tangent 105 degrees. So we got to pick two numbers that add up to 105 or subtract them and you get 105. And you get to pick. You could even start at 300 and something if you want. It just needs to be numbers on the unit circle. I tend to like to keep, if possible, the numbers to be in quadrant 1. I just think those are easier to think about. So I'm going to do a sum. You don't have to, but I'm going to say the tangent of 105 degrees is equal to the tangent of, I think it'd be easiest. Now with tangent, I always want to have a 45-degree angle in it. Either 45 or 135 or 225, all those that are at the 45-degree angles, because tangent at 45 degrees, one of those is always 1 or negative 1. Okay, tangent's always 1 or negative 1. In quadrant 1 and 3, it's 1, and in quadrant 2 and 4, it's negative 1. So that makes for a lot easier math. So if I'm using a 45 in this, what two numbers would add up to 105?
45 and 60.
Okay, so I always put the bigger one first. You don't have to. So let's look at the formula. I don't have these formulas memorized, so shouldn't either. So the tangent formula that is addition is tangent of theta 1, so that's tangent of 60, plus tangent of 45, divided by 1 minus tangent of 60 times the tangent of 45. Okay, that's the fourth bullet on the list. So just find the tangent addition formula. Okay, tangent of 60 degrees. Now that's the same as pi over 3, and it'll probably help you. You could do the sine over cosine thing and figure it out. Sine 60 over cosine 60. But if you can remember, tangent of 60 is root 3 over 3. And then tangent of 45, I said they were always 1 and negative 1. This is in quadrant 1, so it's going to be 1. Tangent of 30, that's actually wrong. I'm so sorry. It's just root 3. But you can do sine of 60 degrees over cosine of 60 degrees, and after you boil all that down, you'll get root 3. 30 degrees is root 3 over 3. Okay. So then that would be 1 minus tangent of 60 is root 3, and tangent of 45 is 1. So I would have root 3 plus 1 over 1 minus root 3. Now that is a correct answer, and this next test is not multiple choice, so you would get most of the credit. But what mathematical, what do mathematicians hate about this? What do they not like? The radical in the denominator. I don't know why. You'll have to ask them. But what could we multiply? What clever version of 1 can we multiply by to get rid of that radical? No. 1 plus root 3. I don't know if that's what you said, Andrew. But 1 plus root 3 over 1 plus root 3. Is that what you said?
Yeah.
Okay, sorry. That's going to get rid of that radical in the bottom. Okay, so this will be the last time this year you'll be rationalizing. Okay, it'll be this section. So if we FOIL, we've got root 3 plus 1, and then root 3 times root 3, the outside is just 3. And then 1 times root 3 would be plus root 3. And then if we FOIL this, we got 1, the negative root 3, and the positive root 3 is going to cancel. And then minus, what's negative root 3 times positive root 3?
Negative 3.
All right, so minus 3. So putting everything together, I've got 1 plus 3 is 4. And then if I've got a root 3 and another root 3, we could call that 2 times root 3. And then on the bottom, that goes, and 1 minus 3 would be negative 2. Now I can divide the negative 2 into each one of the coefficients. So negative 2 into 4 would be negative 2, and then negative 2 into 2 would be minus 1. So minus root 3 is what that would simplify down to. Again, if you get to here, you're getting most of the credit. That last little bit, though, would be rationalizing and getting there. Now that is enough of a lecture to do homework that's due Monday, 6.4a. I'm going to go ahead and give you the lecture for 6.4b now. All right? So this lecture covers the double angle identity. So the second part of the sheet. All right, so our first example is if sine x is equal to 3/5 and x is in quadrant 1, find sine 2x. So 2x meaning twice the angle x, the double angle. All right, anytime you get a fraction, what you're going to want to do is draw a triangle. So if sine is 3/5, we have an x right there. Where does the 3 go? Okay, opposite. And where does the 5 go? All right, hypotenuse. Does anybody know what that is without going through the Pythagorean theorem? All right, it's a 4. So our formula, the sine 2x formula, is sine 2x is equal to 2 times sine x times cosine x. Okay, so the very first formula on the double angle sheet. So that's going to be 2 times, we already know that sine x is 3/5. What is cosine x from this triangle? 4/5. So 2 times 3 times 4 is 24. 5 times 5 is 25. It'll be 24 over 25. This next one, just kind of, it's really easy if you recognize the pattern. So we want to simplify cosine squared of 15 degrees minus sine squared of 15 degrees. All right, looking at the formulas on the sheet, can you see anything that looks like cosine squared of an angle minus sine squared of an angle? What is that equal to? Cosine 2 theta. So that's going to be cosine 2 theta. Well, theta is just equal to 15 degrees. All right, so if theta is 15, what is 2 theta? 30. So this is just cosine of 30 degrees, which on your unit circle is what? Root 3 over 2. So that one is just pattern recognition. Capiche? All right, everybody caught up? Okay. Couple more examples. If tangent x is equal to negative 5 over 12 and is in quadrant 2, find sine 2x, cosine 2x, and tangent 2x. So we're going to pretty much use up all the rest of the formulas. So you have an example of that. Okay, I'm going to draw a triangle, but I'm not going to worry about the negative. We'll figure out the negative and positive part with our ASTC. Okay, so for tangent, where do we put the 5? All right, opposite. Where do we put the 12? Does anybody know what the hypotenuse is without the Pythagorean theorem? 13. All right, but if you don't remember that one, just use the Pythagorean theorem. We're going to use Pythagorean theorem a lot in this section, so use that to get 13. Okay, so first of all, let's get sine of 2x. So sine of 2x is equal to 2 sine x cosine 2x. Come in. 2 sine x cosine x. That's just from the formula sheet. All right, so that is going to be 2. What is the sine in that triangle? 5 over 13. We're in quadrant 2. Is sine positive or negative in quadrant 2? Positive. So it's just going to be a positive 5 over 13. In that triangle, what is cosine? 12 over 13. We are in quadrant 2. So is cosine positive or negative in quadrant 2? Negative. All right, so that's going to be 2 times 5, 10 times 12, so negative 120. And then 13 times 13 would be 169. Okay, let's do cosine 2x. Now we get to pick cosine 2x has 3 formulas. All right? I'd probably pick a formula that just has one trig function in it. So see the third one is, or let's see, the second one is 1 minus 2 sine squared. And we already know sine, we just figured it out, right? So that's a pretty easy one to go for. So cosine 2x, let's pick that one, 1 minus 2, but they will all give you the right answer. So that's going to be 1 minus 2. Sine again is what? 5 over 13. Is it positive or negative? Positive. And what do I have to do to that 5 over 13? got to square it because it's sine squared. So that's 1 minus 2 times 25 over 169. This would be 1 minus 50 over 169. I'm going to put the 1 in 169 over 169 minus 50 over 169. And that's going to be 119 over 169. Now, so you don't think that maybe I'm telling you a false here, let's try one of the others. So let's check it and see if it works with, how about we do the cosine squared x minus 1, or 2 cosine squared x minus 1. Okay, so which one is that on the list? That's the third one on the list. It should be 119 over 169. So we've got 2. What is cosine in that triangle? 12 over 13. Is it positive or negative? Kind of doesn't matter though, because we're going to do what to it? All right, square it. And then minus 1. Okay, so that's going to be 2 times 144 over 169. And you can use your calculator if you don't like squaring 12 and squaring 13. You don't have all that in your head. Use your calculator to do it. Minus 1. That's going to be 288 over 169 minus 169 over 169. 288 minus 169, you might be shocked to know, is 119. So, they didn't lie. You can fast forward through this part.
Mm-hmm.
Okay, one more problem. All right. Headcoming. We said, let's see, originally tangent x is negative 5 over 12, right?
Yes.
Shouldn't have erased all that. Okay, so our triangle was, let's see, 5, 12, and 13. Okay, so for tangent to x, we just have one formula. Tangent to x is equal to 2 tangent x over 1 minus tangent squared x. So we're getting the tangent of twice the original angle. That's what we've been doing the whole time. So tangent we know is negative 5 over 12, so 2 times negative 5 over 12 over 1 minus negative 5 over 12 all squared. So that's going to be negative 10 over 12 on the top, and on the bottom 1 minus 25 over 144. Negative 10 over 12 over 144 over 144 minus 25 over 144. So that's negative 10 over 12 divided by 144 minus 25, I think would be 119, right? So 119 over 144. So So what am I gonna do to the bottom fraction? All right, flip it, so 144 over 119. What can I do with the 12 and the 144? All right, so this would be a 1 and that'd be a 12, right? So that's negative 120 over 119. And that will do the trick for homework 6.4b. 6.4b. All right, so I'm going to kind of be one day ahead of you on all the lectures.